know the change of the energy. So the work done by this force plus the work done by the friction, it should be the change of the energy, right?
Okay.
According to conservation of the energy should be equal from the beginning and the end. So it's 5.6 jumps. It's 1.6. Should be 2.2 for this force. You understand this one? So, for example, an object, there are several forces. F1, F2, maybe even F3, and then it moved from A to B, which is has a distance S, and we know the energy here is energy A, energy here is energy B. The change of the energy is because of those force, right? So energy B minus energy A should be equal to the work of this force.
Okay.
Should be equal to F1 plus F3 minus F2 Fps.
Okay.
Or you can put the energy at the beginning. Plus the work you did on this object should be equal to the energy at the end. Right? And that's how you work on this problem. Is you have the energy at the beginning, you have the energy at the end. You know there's work from this force and from the friction. Work from this force, from the friction, should be equal to the change of the energy.
5.6 minus 4?
Yeah. So 5.6 is energy in the end. And 4 is the energy at the beginning. So 5.6 minus 4 should be the change of the energy.
And 1.2 times
0.5
0.5?
is the work acting by the friction, right?
So we
But you
go,
need to add a minus because it's negative. You need to add a negative.
right. So we do the force is equals to the energy? That's what you're doing? The forces are equal to the energy, right?
It should be always energy. We're talking about energy. So we time the force with distance. So that's the work, right?
Right.
In the end, you should get the resultant. So
But you also have a pulling force too, right?
yeah, that's the pulling force.
5.
It doesn't matter here actually, because you don't know the angle here. So you just need to put the work done by this force. So the work done by this force for example, example, you have P, you have the friction, the initial energy plus the work done by those different forces should be equal to the energy in the end. Right? So that's how you answer this question. You know the initial one in the end, and the work done by these two forces.
Okay.
You understand? No?
Mm-hmm.
And in this case, you don't need a force. And then number 5, an object is moving.
But with number 5, you would take the integral, right? Because it's the area under the curve.
Yeah,
It would be easier to take that, right?
yeah. You need to calculate the area. That's how you. 6, 8, 2. That is -10. That is x. So it should be fx dx. That's how you calculate the area of here and here, right? But remember, if it's below the x-axis, it should be negative. Here is negative work. So when you calculate, you know, here is 4, here is 20, here is 2,